Greetings and welcome to our session where we'll look at how to migrate and modernize your open source and Linux-based solutions with Azure. Migrating to Azure is your path to an agile, secure foundation for innovation in AI, and that is the agenda we'll be covering today. Adopting cloud and cloud-native technologies gives you faster application development, intelligent automation, consolidation of tools, and retirement of technical debt, all with comprehensive security and governance, giving your teams higher productivity and more time to focus on business innovation. So how do we get there? One easy way to get started is by using Azure Arc to bring your on-premises resources under Azure management, immediately benefiting from a unified control plane, that single pane of glass with consistent policies, monitoring, security in a hybrid environment. Or you can jump directly to retiring your biggest CapEx spend, your hardware, by migrating workloads to Azure with immediate cost savings, improved resilience, and scalability, allowing you to maximize your investments. Now, no migration is quite like the other, so it's important to consider your use case and desired business outcomes before you get started. What is your desired performance for your application or solution? How do you enable developer and user productivity while maintaining security and compliance and ensure the solution aligns with your long-term business roadmap? These are some of the factors you'll need to consider as you decide whether you're going to migrate or modernize, and most likely a little bit of both. With a comprehensive set of offerings designed to run Linux and open source, whether you choose to rehost, replatform, refactor, or re-architect, Azure meets you where you are in your migration and modernization journey. Regardless of which version or combination of the 4 Rs you end up pursuing, there are some common requirements you'll have that Azure can help with. Developers need flexibility and choice to leverage their existing skills and build apps in their preferred language, using the open source tools and third-party integrations they are familiar with. Whether you build apps with Java, Node, Python, or .NET, we've got you covered. And we help development teams code, collaborate, and ship their apps while working on remotely distributed teams. No matter where you are, every developer is welcome. When we talk to customers about their needs for running business-critical workloads, there are 3 main themes that come up over and over. First, comprehensive infrastructure that delivers choice and flexibility and that can grow as they grow. Second, security and compliance is often the top concern for customers and can be a barrier to cloud adoption. What many customers are starting to realize is they cannot match the huge investment Microsoft is making into security and compliance every year. Third, cost effectiveness and cost optimization are also always top of mind. Microsoft invests heavily in all these areas on an ongoing basis. Let's start with choice and flexibility. Justin, what does Azure have to offer for cloud-native and Linux workloads?
Open source software runs on an operating system, and for most developers today, that OS is Linux, which is why more than 65% of customer CPU cores on Azure today are running Linux. And it's not just our customers. Hundreds of Microsoft's own services run on Linux in Azure, including Xbox, Microsoft 365, Azure Kubernetes Service, and many more core Azure services. It may come as a surprise to some folks, but we even have our own distribution, Azure Linux, which we use for those Microsoft services and make available to customers as a container host for Azure Kubernetes Service. That's optimized for Azure and offers enhanced performance, reliability, and security. And lastly, of course, the latest AI workloads such as OpenAI, ChatGPT run on Linux in Azure. On Azure, you can take advantage of a broad ecosystem of open source technologies that includes databases like Postgres and MySQL, cloud-native technologies, and large language models allowing you to run your workloads using your choice of open source software. Of course, that includes the choice of Linux distribution, because we collaborate with the leading Linux publishers like Red Hat, Canonical, and SUSE, as well as the broader Linux communities to ensure an optimal experience on Azure, whatever your preferred distro. Kubernetes provides a significant amount of benefits for your applications, not having to worry about configuring your virtual machines, your networking, or your storage, and declarative configuration of your application state maintains desired state for what your applications need to do. This is great to make sure Kubernetes always strives to keep your applications where they need to be. Kubernetes will take care of placing your workloads on the infrastructure that satisfies the needed capabilities, for example, GPU workloads, and increasing developer velocity as developers can run containers on their laptop and guarantee that configuration drift and dependencies are no longer an issue. Taking advantage of the limitless scale of Azure, Kubernetes can automatically scale your workloads and as such your infrastructure to react to your customer demands. Customers choose Kubernetes for its flexibility, scalability, portability, and the ecosystem. AKS preserves these attributes and builds on top of them. We want to make AKS the most advanced Kubernetes platform, and we have 4 areas that we focus on. Making it easier for developers to be productive, providing recommendations but still allowing flexibility for your own way of doing things, and providing a secure, managed Kubernetes service with managed add-ons and nodes, and ensuring a resilient, scalable platform for customers to run their mission-critical apps. Azure has an official support policy that we welcome all flavors of Linux, and we work across the industry to ensure that just about every major distro, and most of the smaller ones, can run in Azure, and to make a wide selection of images available in the Azure Marketplace. This is the starting point if you have a specific distro you're looking for, as it houses thousands of offers from publishers across the industry, including base OS images and applications. You can even use a base image from the marketplace, customize it using Azure Image Builder, and store that image in your own private image gallery. We're an open platform, and as such, you are empowered to use the tools that are right for you, whether it's GitHub or Azure DevOps or monitoring tools for your cloud-native workloads. Your AKS environment is fully integrated with the Azure ecosystem for identity through Entra, secure secret store through Azure Key Vault, and providing recommendations for your environment through Azure Advisor. As well as AKS, you can run your lighter weight workloads on Azure container instances, and also the ability to run your workloads on Red Hat OpenShift, which is a collaboration with Red Hat. Finally, Microsoft is deeply involved in the Kubernetes open source community, contributing Helm, Cada, Gatekeeper, and many more back to all Kubernetes users. For someone who doesn't have a specific distro they're looking for, they would start with a list of endorsed distributions. We currently have 7 endorsed Linux distributions, including Alma Linux, which we added recently. Another change is that CentOS was moved following its end of life, and for those impacted by that, we do have a page in our docs that provides guidance and migration options. Endorsing a distribution is not really a recommendation per se. Let's talk a little bit more about the criteria for endorsing a distribution. First, we have a contractual agreement with the provider of the distro. Second, we have engineering collaboration forum in which bugs, issues, enhancements, and escalations are discussed. Next is we're seeing a sustained, strong market demand. And finally, the publisher maintaining an updated infrastructure in Azure to enhance the user experience. At Ignite last year, we announced the Community Image Gallery, and we've seen a number of community distros embrace it as a way to easily share their images. In particular, we've worked closely with Fedora to add Azure as an official supported cloud platform for that project, to bring their images to the Community Gallery, and also to enable Azure in Fedora Cloud, so users can simply create a Fedora-based VM directly from the Fedora webpage. This is a great example of how our upstream Linux engineering team is engaging with the community to make deployment on Azure as simple as possible. Customer workloads come in all shapes and sizes, from dev and test and second-generation applications to the most demanding high-performance computing and AI workloads. Azure offers a broad portfolio of compute infrastructure options to match, with Intel-based VM having some of the most options, ranging from 1 core to 1,792 CPU threads, and from 1 gigabyte all the way up to 30 terabytes of RAM. Among our new VMs we have generally available are the latest 6th generation D and E series Intel virtual machines for general purpose and memory optimized workloads, covering a vast variety of workloads with different CPU and memory needs. Also recently generally available are the 2nd generation compute optimized FXV2, ideal for workloads like databases, data analytics, electronic design automation. By choosing the right VM and utilizing the latest VM offerings on Azure, you can ensure you achieve the optimal price performance for your Linux workloads. With our latest 6th generation Intel releases, we achieved significant performance improvements from our previous 5th generation VMs, with up to 27% increased CPU speed, 3 times larger L3 cache and read IOPS, and 46% larger SSD capacity. On top of these improvements, we're enabling our proprietary Azure Boost technology for all new Intel VM SKUs, allowing these VMs to achieve up to 400,000 IOPS and an industry-leading 12 gigabytes per second remote storage throughput. Azure Boost is one of our most significant advancements in infrastructure that moves virtualization processes traditionally done by the host infrastructure onto dedicated hardware, enabling greater network and storage performance and enhancing reliability and security. We continue to invest and bring new Intel infrastructure options to the market, enabling some of the most demanding hyperscale apps and performance-dependent workloads across all operating systems. Last October, we announced the general availability of Azure's first-generation ARM-based VMs based on our in-house custom-built ARM64 Cobalt 100 processors. The new Cobalt 100 VMs offer up to 1.4 times the CPU performance, 1.5 times the performance on Java-based workloads, 2 times the performance on web servers, .NET, and in-memory cache applications, and 4 times local storage IOPS, and are more power efficient than our previous generation ARM-based VMs. These VMs are priced to have up to 50% price performance compared to our previous generation VMs. As of January 2025, these VMs are available in 21 Azure regions and are used by companies in various industries, including Databricks, Snowflake, Elastic, and Amadeus, a major technology provider to the travel industry. Azure Disk Storage offers a comprehensive set of block storage solutions for every workload with a wide range of sizes, price points, and performance characteristics, so you can get the exact storage that you need. Azure Elastic SAN is a cloud-native service that offers a scalable, cost-effective, high-performance, and comprehensive storage solution for a range of compute options. You get the same simplified management experience in the cloud as with your on-premise storage area networks. With Elastic SAN, you also gain higher resilience and minimize downtime with rapid provisioning. For your most intensive and demanding workloads like SAP HANA, UltraDisk delivers the best performance and offers the unique ability to configure capacity, IOPS, and throughput independently and dynamically scale with performance, so you get the optimal performance and price for your needs. Premium SSD gives you the best balance of cost performance and is ideal for most of your enterprise production workloads. On Premium SSDs, we also offer our on-demand bursting, which is currently in preview, which allows you to burst your performance up to 30,000 IOPS and 1,000 megabytes per second whenever you need it. Premium SSD V2, the next generation of Premium SSD disk storage that offers the most advanced general-purpose block storage solution with the best price performance. Premium SSD V2 offers sub-millisecond disk latencies for demanding I/O-intensive workloads at low cost. And for your workloads that need consistent performance but is not as data-intensive, we also offer standard SSDs. And for cost-efficient storage for backup or test dev, we offer standard HDD. To achieve higher availability for your workloads, we offer zone-redundant storage on Premium SSD and standard SSD. ZRS provides synchronous replication of data across the zones in a region, enabling disks to tolerate zonal failures, which may occur due to natural disasters or hardware issues. We also offer single-instance SLAs for all disk types with an industry-best SLA of 99.9% for VMs using Premium SSD or Ultra disks. These include the ability to run highly available applications with redundancy across zones, different SKUs offering price performance options for different workloads, and integrated security, including encryption, with the ability for you or your users to bring their own keys. So here we have a GitHub repository with a couple of services for a demo application, and there's some REST APIs, some front-end, some back-end services as well. What we want to do is take some of this code and actually deploy it onto a Kubernetes cluster. Having a look at the code itself, we can see it's some REST endpoints written in Rust itself, but we don't have anything here which is related to creating a Docker container or a container image or deploying this to a Kubernetes cluster. So as an application developer, I worry about my code. I don't worry about the systems that it's going to be deployed on. So let's go ahead and actually deploy some of our code onto a brand new Kubernetes cluster. And we'll use AKS Automatic here. AKS Automatic is a form of Kubernetes or a form of AKS, where we basically deploy best practices for you, and we take care of a significant amount of running Kubernetes. So first thing we need to do is to actually connect our GitHub repository we were just looking at into Deployment Center. And we're going to select the organization, as well as then the repository, which in this case is going to be product service. And now let's go ahead and select the branch that we actually want to build against. We're going to create a GitHub action, so let's give that a name, in this case, Pet Store. And what you can see here is that the deployment center has actually seen that it's Rust already. So it's going to build a Docker image specifically for running Rust and specifically for my application. And we're going to publish that application on a port. So what port is that application running on within the container itself? We don't have a container registry, and container registries are a way of being able to store container images to deploy to Kubernetes. So let's go and give that a name. And then we'll go and select which region we want to be able to deploy this into. You should always have your container registry as close to your Kubernetes clusters as possible so that you can pull your images much quicker. So we're going to give the new container image that we're going to create a name. And in this case, we'll give it the same name as the service itself, product service. Now, what's happened here is that we're actually going to go ahead and create some of the Kubernetes manifests or the Kubernetes YAMLs to actually deploy this into Kubernetes. I, as a developer, haven't had to do that. We're going to deploy it into the Pet Store namespace on our Kubernetes cluster. And we can see that we've actually created the deployment and the service here as well. Now let's have a look in terms of where we're going to create the Kubernetes cluster itself. We're going to create it in the resource group automatic build. We're going to set it into the same region as our container registry. And let's just go ahead and get that deployed. So what's happening now is that your cluster is being deployed. We haven't had to worry about that as an engineer or a developer. And what we're also doing now is creating the manifest, the Kubernetes manifest, to be able to deploy your application. And all of this is actually going to be committed into my original GitHub repository, and it's in a pull request. So I can go now over to GitHub, have a look at the changes that Deployment Center has actually made within my repository. And then when I go and approve that pull request, what will happen is that my application will automatically be deployed onto the Kubernetes cluster. So you can see here, 4 files have changed within here. I'm going to go ahead and merge that pull request, confirm that. And what happens now is that it's going to trigger the GitHub action that was defined for us as part of the deployment center. And it's currently building the container image. So it's pulling all of the source code from the repository, creating the Docker image itself, pushing that automatically to the container registry. And now it's automatically deploying that to the AKS cluster that we created. Now, at no point here have I had to worry about Kubernetes, how I'm publishing something, how I'm creating the Docker image. This is all being done automatically for me. And so when you're thinking about migrating your applications over to AKS, if you're an engineer or a developer and you're working on the source code and driving that business logic through your application development, this is a really, really easy and quick way for you to be able to get up and running, to be able to get your applications migrated over to AKS. So let's have a look at the service that we generated, and we've automatically published a public IP address. And here we can see that we're actually looking at the API itself that was published. So we've gone from code to Kubernetes cluster creation to deploying all of that for you.
Now let's talk about the second customer priority, security. It's no secret that we live in an environment of increasing attacks. Look at the latest example, the XZ-utils attack, where an attacker spent years building up the trust of the developer community only to be thwarted by a vigilant Microsoft security researcher. These types of issues have opened everyone's eyes to the scale and scope of the potential threats out there and put everyone on alert. Security always needs to be top of mind. So we start by making sure the images made available in the marketplace are a secure starting point. We validate the publisher, followed by certification of the images themselves, and we scan these images in the marketplace on an ongoing basis. Over the last couple of years, we've significantly expanded the range of tests applied on ingestion, including a full vulnerability scan, again, continuously applied after the image is published. The next level is ensuring that the operating system you're booting is itself secure and unmodified. Azure Trusted Launch ensures the integrity of the OS image, both at boot time, with guest attestation, and again on an ongoing basis. And I'm pleased to share that all endorsed distros in Azure will support Trusted Launch. We also provide a secure baseline for Linux in Azure so you can audit conformance to a subset of the CIS standards. We announced Secure Baseline at Ignite last year with an enhanced audit experience that is now fully aligned with CIS. Next up, we have auto remediation. We open source the code, enabling collaboration both across the company and with the broader Linux community. Let's take a look at some of the highlights. We are creating a Linux native experience for compliance and auto remediation. We support hybrid use cases, giving you a holistic view of compliance and use of auto remediation across clouds, Azure and non-Azure, and on-premises through Azure Arc. The current baseline has around 63% coverage of the latest distro-independent Linux CIS baseline. Upcoming new baseline content, which will be fully aligned to the latest CIS standards, starting with Level 1 controls for servers and later L2 controls, are coming as well. Auto remediation is against the current baseline content. As new content becomes available, auto remediation will be available for those as well. We also have Microsoft Defender for Cloud, which offers comprehensive security for your cloud-native applications, built natively into the Azure portal experience. It provides near real-time cloud detection and response, vulnerability scanning, and proactive risk management. Our protection of Azure resource is the most complete compared with other security vendors, covering compute resources, whether on-premises, hybrid, or multi-cloud, including AWS and GCP. We also provide protection all the way down to your databases, storage, service layers, spanning resource management, app services, Key Vault, and networking. With full visibility into your multi-cloud and hybrid infrastructure and applications, we empower your teams to identify, prioritize, and mitigate risk early, ensuring compliance and helping prevent breaches through continuous posture assessment and contextual insights. Defender for Cloud also helps reduce threat mitigation time by up to 30% with prioritized alerts and an integrated incident investigation experience, according to a recent Total Economic Impact Study, or TEI, from Forrester Research. And for a number of VM, container, PaaS, and SaaS offering, Azure offers confidential computing. In addition to protecting data at rest in storage and in transit through the network, confidential computing helps protect data that is in use. At a minimum, this protects data in memory from hackers, unauthorized third parties, including cloud operators. And in some use cases, it can even protect data from tenant and application administrators. The level of protection is based on the processor's memory access firmware and therefore cannot be overridden by exploits in the cloud hypervisor. All confidential computing technologies include attestation to allow the developers of sensitive workloads to ensure those workloads are running in a properly configured, confidential computing, trusted execution environment before secrets are released and sensitive code or data is loaded into memory. Microsoft has taken a full stack approach across infrastructure, containers, and PaaS SaaS for confidential computing, and has the most comprehensive confidential computing offerings in the public cloud. Notable new offerings include confidential containers on Azure Red Hat OpenShift, which is in public preview now, confidential clean rooms, confidential inferencing with the Azure OpenAI Whisper mode, and fourth generation AMD EPYC confidential VMs, all in preview now. Azure offers the most flexible licensing options for deploying Linux workloads. You can choose from a range of free community-supported Linux distributions, including Debian, Alma Linux, Rocky Linux, and Fedora. If you require a commercial paid Linux distribution, such as Red Hat Enterprise Linux, SUSE Linux Enterprise Server, or Ubuntu Pro, you have the flexibility to choose a pay-as-you-go model, paying only for the resources you use, or a bring-your-own subscription model, allowing you to use your existing subscriptions in Azure at no extra cost. Azure is the only cloud to offer Azure Hybrid Benefit, which is a unique licensing solution that enables bidirectional conversion between pay-as-you-go and bring your own subscription for your Red Hat and SUSE workloads, including post-deployment conversions. Azure Hybrid Benefit can be combined with other offers like reserved instances to get additional savings. While we are on the topic of managing costs, I'm excited to announce a promotional offer on the latest Linux virtual machines. For a limited time, you'll be able to save up to 56% on select Linux VMs across multiple regions. To take advantage of this offer, purchase a 1-year Azure Reserved Instance virtual machine for a qualified VM SKU and region. Details on the offer are available on aka.ms/Linux promo offer. Be sure to bookmark and stay tuned. So, we've talked about AI readiness, security, and cost in the cloud, and we hope we have demonstrated the value of cloud migration by now. But what does it take to get from point A to point B, and how do we get started? There are many ways to migrate to the cloud, and feel free to bring your own approaches and tooling, but let's make it real by looking at how you can take the first step into Azure with Azure Migrate. Azure Migrate is our first-party migration tool. It allows you to quickly discover and assess your hybrid and multi-cloud environments, create a business case for migrating, and when ready, migrate your resources into Azure, including validation in the cloud and cutover. And best of all, it's completely free. Let's look at a quick demo to illustrate the ease of use and value Azure Migrate business case brings to your environment.
The Azure Migrate Linux migration demo. To migrate your Linux machines, you can use the Azure Migrate service available on Azure portal. Once you navigate to the Azure Migrate, you can select one of your existing projects, or you can create a new project in your desired location. Then you will start the discovery of your on-premises IT estate, which you want to migrate, which will include your Linux machines and other workloads like databases and web apps. We have two ways to do the discovery, using import, which is the offline method, or using the appliance, which is the online method where you will deploy this appliance on your on-premises, which will do all the discovery and share the discovered metadata with Azure Migrate. Here, you will see in this particular project, we have discovered 66 machines with all the different metadata for those machines, including the operating system and the other details like storage, memory, disks, boot type, and other details which are required. Once your discovery is done, you would typically go and build a business case for you to understand what's the TCO benefit if you move or if you migrate this inventory to Azure. I've already created one, so let's take a look how that looks like. This is the business case overview where you will see the TCO comparison and the cost incurred that you will incur on the on-premises versus on Azure. And this is the potential savings that you will have if you happen to move these details to Azure. Now, you will also see these are some additional Azure, savings we are highlighting with Azure Hybrid Benefit, which is if you are migrating your RHEL or SLES machines, you can reuse your existing licenses with those vendors and continue with those vendor relationships and keep those licenses. And these are some additional savings then you will incur because you don't need to pay for the license when you come to Azure. You can reuse the same licenses and you only pay for the compute. Once your decision making is done, which is part of the business case, you would start planning to do the migration, which you can create a assessment for, and you would typically create an Azure VM assessment. Then in one of the assessments, let me show you how it looks like. You would basically get all the details of the machines that you are assessing. In this case, we have assessed 13 machines, out of which we are saying it's one is completely ready, 10 are ready with conditions, and then there are some other statuses, along with the cost details for compute, storage, security. And again, we are highlighting the AHP benefit, AHP saving as well. Now, on the readiness part, you can check all the machines that are assessed here, what are the current status, and for machines which are not ready or ready with conditions, we also give you details on how you can or what is the issue and how you can make them ready. Like for this particular machine, it is powered off on the source, hence it cannot be migrated. So the recommendation is that you need to ensure the VM is powered on when you are migrating this particular machine. Now, let's say your plan, you know how to make them ready, and now you want to go and migrate. Then you would start with the replication process, where you will come here and click on replicate. Then select all the required details over here. Like in this case, we are doing it from the VMware. Select the appliance that was installed and which will do the migration. And when you click on the replicate, it will ask you details if you want to reuse some of the information from the assessment that you created, or you can also go without an assessment. We have one assessment created, so I'm just picking up all the machines that were part of that assessment. So let's say in this case, I can select a few machines, but just for simplicity, I'm just selecting one of the machines and selecting all the other details which are required. Like I want to migrate this to West US2 region. This is my storage account. This is my subscription, and this is my resource group. Now here again, if this was a RHEL or SLES machine, I could have selected Enterprise Linux here, and it will give me all the benefit with this. Now here, if I just go in this selection, it will help me migrate my machine to Azure. Thank you.
Thank you for watching this demo. And now back to you, Justin.
Thanks, Klaus, and thank you for joining us today. Here are a few resources to help you get started on your journey to Azure. To accelerate your projects, I encourage you to leverage Microsoft programs designed to help you at every stage of this journey. From planning and execution to scaling and optimizing, we're here to partner with you. The Migrate Linux and PostgreSQL workloads to maximize workload performance guides you through migrating Linux-based workloads to Azure, leveraging Azure IaaS and PaaS solutions, and optimizing PostgreSQL database performance. You'll gain expertise in security, scalability, and Azure Cloud Services to enhance workload efficiency. Start learning today at aka.ms/migrate Linux PostgreSQL and take the challenge at aka.ms/migrate to innovate challenge. The Migrate to Innovate challenge covers some of the fundamentals of migration. This 30-day challenge ends on March the 31st to make it fun by completing the plan, and you can climb the leaderboard and earn a badge. Let's unlock the power of Azure together. As we wrap up this session, I'd like to leave you with a short video montage featuring real-time customers running Linux on Azure to modernize and innovate. Enjoy the rest of your event, and thank you for tuning in.
We live in a world where trust is critical to our customers, our suppliers, our agents, and our employees. And our technology is core to providing that trust.
Our ESB solution works on Linux on Azure. Our operations have gone uninterrupted, and we've realized a saving benefit of more than 20% compared to our previous on-prem setup.
Red Hat OS, running on Azure, reduces the issues of security measures and patch updates. License management is now simplified with a pay-as-you-go model. Cost savings are about 40% compared to existing on-premise systems, and it is highly compatible with existing core systems.
In order to train the world's best AI models, we have to ingest vast amounts of data into our data pipelines. Azure Blob Storage scaled accounts have really helped us grow our data pool without growing our operational complexity.
Our customers expect good insights into the expected future returns and that our software itself is reliable.
We onboarded the team to our cloud-native platform by educating the engineers in collaboration with Microsoft and Red Hat. That allows for both platform engineers and software engineers to declare everything as code, which is a superpower provided by OpenShift solutions.
With Defender for Cloud, we are improving our data security, vulnerability management, and data governance. Working with Microsoft, we tapped into the vast capabilities of Azure integrated stack, high availability, low latency, and scalability to start creating advanced generative AI solutions. With Azure infrastructure underlying our ongoing AI innovation, our customers can get the support they need when they need it most.